Hello, Commentary from Lumpology, and welcome back. So today we're going to be learning the various math types available in the C Math library of C++. So in our project folder, I'm just going to modify the compile script so that we are no longer including glut as we were in the last episode, so that we're just compiling C++ 17. Next, what I'm going to do is I'm going to go to the main.cpp that we created, and I'm going to open it with the Atom editor. In here I'm going to replace our previous code with the following types. /include, I'm going to include the IO stream. I am going to include the library CMath, and I'm going to include the library CStdlib. Next I'm going to say using namespace std followed by int main with a return 0 inside. So here's our format. So CMath gives us the functions. CMath is a migrated library that was pulled originally from C. In the format I believe is referenced as math.h. However, now it's been modified rather significantly with C++ 11 to have a whole bunch of new features. And yeah, so basically we're going to be just going through the overview, and I'm going to show off how you can read the documentation as well once we've tried out a few types. So some things to note right off of the bat. Math types can be bound mainly around the types the integer, the float, and the double. And these are the main types that are used for this. Generally speaking, when it comes to math problems, we will not use a bool, and we will not use a string. However, in this tutorial, I will be showing off some math functionality using strings, as they are incredibly versatile items in C++. So let's introduce some of the math types in C. So I'm going to create a local variable. It is going to be a float, and in this float we called x, and float x we'll just create float x. So then we're going to say x equals, and we're going to say show off the basic operators 1 plus 1, and then we can have divided by 2 times 2. And these are the only recognized math operators in default C++. There is one called mod, but it is not really as useful in this scenario. I will cover that some other time, but for now we're just going to be covering math types. So things we do not have access to. We do not have access to exponents or logarithms directly off the bat without using CMath. So this equation here will need a semicolon, of course, and then we will have a program just out, a little line down here called cout, and we're going to say x and O. So this is what we're going to do here, and we're going to do a system call, and we're just going to throw pause null into here. So if we compile this, you can see the answer is 1. Continuing on, let's get into some math types. Okay, so our first and possibly most important math function we're going to do is we're going to do power. Power contains two variables that will be separated with this decimal, comma, and we can say 2 to the power of 2, and if we compile this, and then we can go on from there. So in the CMath library, other types we can use inside of this function, we can use the cosine. We can also do sine. We have access to tangent, and of course arc, cosine, and arc tangent. There's also an arc tangent with 2 parameters, so that'd be a y and an x, and that's when you get into graphing, which is something that we can do later in the tutorial series. Then we also have some various log types. This is a log type that uses two types. So this is the natural log. So I believe the natural log uses the function e, the number e, Euler's number, and then we can just say log 10 for a 10th log. So log 10 is normally combined with a division symbol to get any log to number you'd like. Once again, this will come in handy when graphing. Other things we can do, there's an exponent, there is a s, I believe the exponent one is exp, and it has one input number type, so you can also have a sqrt, square root, and then I believe there's also cbrt for cube root. They also have a function for computing the hypotenuse, and various other things like that. So similarly, one very important thing that will be used often is ABS, so that's absolute value. You put a value in here, so if I wanted we can put other, also I should mention you can put, if I wanted to put x in here, I could, or if I had another, like another value, like float y. Generally we work within types, so float y is 2, I could put y instead of x along with the 2 in here. Similarly, so also another thing we can do is we can put other statements inside of this, so the power of negative 2 is in y, so of the absolute value of y. So if we get this same answer, we should get 4. So if I actually compile this and run, 4. And that's because we removed the negative. Absolute value is very useful, and then if we want to make it negative after absolute value, just times by negative 1. So that's all good. There's also statements that come along with the library. We have there's a few values we can use. We can use nan, though this isn't recognized. It means not a number. We also have infinity. And I believe there's other statements like huge value, and these just are different numbers. I highly recommend looking at the reference. You can find that in the description below. I believe the types recognized in CMath are double and float. However, they work just fine with an integer, though you will lose precision if there's the decimal involved, or a decimal result. So that's the basic overview of the library CMath. I highly recommend going over the documentation for further checking it out. But now we're going to go over math with strings. So basically, instead of all of this, we're going to make a string. So string x equals, and string x is going to be equal to 2. But alas, 2 is locked in a string, and you cannot do math functions with strings very well. Similarly, you cannot put an integer in a string. For example, if I said int 6, int I equals 6, and capped that off, and then I said string s equals I, and then I outputted s. Let's see what string s comes out to be. So if I compile this, doesn't like it. See? Not an acceptable function according to the results here. So what we're going to do, we are, no, I should probably actually include string in the header, just for safety's sake. I know I believe it was updated recently, wherein you can now, you can call strings without the header, but it used to be you had to call the string header every single time. So something we're going to need to make math with strings work, we're going to need to include a thing called a library called Sdream, which basically means string stream, and it's going to give us some functionality we can use. So because we can't do this, we're going to instead do something else. So there's so what we're going to do is we're going to find some way of putting the number 6 into this string. So in this case, we're going to say it's going to be x. So first of all, I should mention that you can put two strings next to each other. So if I wanted to make the number 22 using two strings, like x and y, I could actually say s equals x plus y, and I believe that will give you something very interesting. Like so. The plus symbol when using strings adds them together, so 2. So there you have 22. So that's just putting two strings together. You can do this with any word or class or whatever. But next, we want to put 2, we're going to say 2a, this one's going to be a, this one's going to be a, this one's going to be, and now we want to find a way to put I, so AB6 next to this, so add the number on the end of the string. So what we're going to do is we're going to say string. So what we're going to do is we're going to create a string stream data type, and basically we're going to call string stream SS. I believe that's like the universally accepted definition. And then we're going to say SS, and then we get to pass stuff out or in to SS. So because we're passing stuff into it this case, so we're going to pass stuff into SS. So we want SS to be, we want I to be passed into SS, and then we want to pass the value, the new value that's in SS, out to the string. We're going to make a new string. It's going to be string Z, right there, and we're going to pass it to Z. That way, when we put the new string together of Z, we can combine them together. This needs a semicolon, and we should have AB and the number 6. So, compile this, and if we run this, AB and the number 6 is in the shell. So that's just merging. That's how you use the string stream to convert between them. But what this also means is, if we wanted to, we could pass if we passed Z in, now Z S is equal to 6, we could expand on this and we could say string stream, and we could say ss2 ssb. It's probably better. And we're going to say ssb, and we're going to pass in s. Now we're going to say actually, we're going to add, we're going to put z there, so it's going to be 66. And then what we're going to do is we're going to say, after this, we're going to pass s in. So SSB is now 66. And we're then going to say SSB, and we're going to pass it out to I. And now we're going to output I. And that is the integer value. And the value is 66. So welcome to math with strings. Exceptionally useful operators. You can merge numbers from various sources. So another question might be like, what if it was 6 and then you had a letter G, the letter G, and you compile it? Again, what would happen? Well, it's still 66, it just ignores the letters. That's what StringStream does. So basically, you can take you can take string values and you can turn them into data values like an int or a float, and then you can take the float and you can put it back into the string, and that's a math of strings. Because now that I have I right here, I can say I equals I plus 1, and then if we compile this and run output, it's 67. So that is the math. That's math with strings. It's way more. Math with strings can be a lot of fun and is exceptionally useful for all kinds of things. If you're trying to put a cryptic message, you can just pull numbers out of it. There's all manner of uses. And for example, one thing that is available in the I/O stream is the matter of passing the user input into things. So if I wanted to say that, if I just set if I got rid of this so that I is just that, but I then I'll get rid of this so it's just z, and I'm going to say cin, and I'm going to pass the value of cin into z, into the string z. Now that it's in z, it's going to get passed. It's going to get passed into the string s, where it's going to be converted and passed into the value of I, and what I is going to be equal to is the number we put into string. So this is like typing a password or something and extracting only numbers from it. So if we do this, run this code in the PowerShell, compile it, and then output, the console is waiting for input. We've basically enacted the console command known as input, I believe it's set/p or set/I. I don't know what it is, but anyways, we can now input into here. So if I put in hi for 2, it outputs 0. And now we get into the kind of jankiness of working with this kind of stuff. So if we do run it again, if I say 66, it outputs 666. If I said 66 high, oops, I close it. If I said 66 high, it pulls out the 66, but if you put it before. Anyways, that's just stuff you can do with it. Know your limitations. But if I say nan, oops, 0, cool. Anyways, this is the amazing stuff that you can do with math with strings, and welcome to the world of C++ and math. I'm Quintradi, and I'll see you in the next video. In the next video, we should be covering, back a bit, we should be covering how to use documentation. Or we may just skip that and go to reading a file and writing a file. Or system stuff. I don't know. I'll do one of those. Thanks for watching. Okay, just me going through the editing of the footage now, and I'm realizing now I forgot to mention a certain function that is possible to use in place of taking a string and converting it to an integer the typical way using Sdream. Obviously, you have to do, to convert it into a string, you have to use Sdream, but there is actually a way. If I wanted I to equal, here, if I had string z, and int I, and if I had string z equaling 100, and I said I wanted I to be equal to string z, I could say I equals the atof function of z dot c underscore str with 2 brackets. So what this is atof is a function that converts type to a number, but it only converts a C string. That's a string of chars, like I showed off in the second tutorial of the series. So because of that, we have to cast z as a C string. So what we're doing is we're saying dot, and that's basically we're accessing another bit of memory within the data type. And this one is C underscore str. I will link the documentation for the C++ string below, so you can view the various basically the various subcommands that you can use along with Z. So this is this is a way you can cast Z as a C string within atof. So if I compile this and output I, so I believe project, bring it over here, compile this. Oh, I did that wrong. This has to be in quotes. So just quickly do that again. Alright, now it's compiled. If I run this, you'll see it's 100. So that's just wanted to get that out there. For redundancy's sake, I was showing off Sdream, but atof is a much simpler path and doesn't require allocation of new memory to pull off. So just keep that in mind for converting types. Sdream is actually incredibly useful still, but if you just wanted to use atof, you can. Another thing I should mention, atof can fit within an absolute value statement, like so. In case that's useful. I know when we get into allocating dynamic memory, this will come in very handy. Absolute value of the atof of a string casted. But anyways, just putting it out there that that's a possibility also.